Nox is motivating wellness. Hello and welcome to Motivating Wellness with Dr. J. I'm Jay Wilkins and I'm the founder and the formulator for Nox. And on these video episodes, we're going to be discussing and have guests that are doing the same thing, that are motivating wellness. And certainly that is true of our next guest. Our next guest is a friend of mine, Dr. Shawn Green. Presently, he is advising on strategies to address nitric oxide deficiencies for the prevention and treatment of age-related chronic diseases and infections. While serving the Medical Service Corps at Walter Reed, Shawn published the first series of papers showing how nitric oxide is regulated in limiting the growth of intracellular parasites, where he received several life science awards, including the Meritorious Service Medal from the U.S. Army. He was awarded several patents and published over 100 articles in such journals as Science, Nature, Nature Medicine, Cancer Research, Journal of Immunology. Dr. Green served on the editorial board of the American Society of Microbiology and as an editorial reviewer for several biomedical journals. So good to have you with us, Shawn. I first met you at in Anaheim at Expo West, I think back in 2014. Expo West is sort of like the Disneyland of natural medicine, right? 250,000 people converge into Anaheim, all these tree huggers and hippies and people that love organic stuff, right? And that's where I met you and first learned about these saliva strips that you invented, and using these as a biofeedback mechanism to be able to really know your nitrate and thus your nitric oxide potential. So I love the idea. So now your latest patent pending invention is the two-padded nitric oxide indicator strip called the Myfit Strip. So now, 7 years later, we're finally able to work on some projects after hours of discussion of different things that we could do together. And here we finally are. So as you can see, Shawn, I got the Spit, Eat, Repeat shirt on here, right? And you are 2/3 of this equation. You are the spit and you are the repeat. I'm trying to be the eat guy, create some things that can help people to really motivate their wellness. And so we thank you, Shawn, for joining us today.
I'm delighted, Jay. Thanks for the invite.
You got it. So we're going to blast right into this. Just give us a brief synopsis of what is nitric oxide.
Sure. Nitric oxide, as you probably conveyed to your colleagues and audience already many times over, it's a small, short-lived gas or pollutant, but yet our body is very efficient at making it. Nearly every cell in the body makes nitric oxide or has the capabilities to make nitric oxide through these different pathways. I was just alerted just in this past week that now our basic biology books in high school have put the third gas in those biology books. When we all grew up, we learned about oxygen. We learned about carbon dioxide and the importance of the red blood cell carrying these two gases. Well, our kids, our grandkids, are going to learn about the third gas that the red blood cell carries. And in that context, if we don't have nitric oxide, Jay, as you well know, those little red blood cells that are carrying oxygen to the distal parts of our body that are in need during hypoxic conditions or exercise or whatever it may be, if nitric oxide is not carried with it, oxygen is not effectively delivered. So the nitric oxide serves as a cofactor. When those red blood cells go to those distant sites, it's released in very simple terms, helps dilate those vascular beds, thereby facilitating oxygen delivery. So again, it's a very old field, but yet it's a very new field in terms of as we talk to consumers and others that are just interested in improving their day-to-day health. the importance of nitric oxide. But nitric oxide, again, our body makes it. Almost every mammalian, all the way down to insects, make it. It serves as a regulatory molecule. In the case of the example I cited for vascular homeostasis, it serves as a molecule that plays a sentinel role in the case of infectious diseases. So it's truly pleiotropic in nature. And without it, we can't exist.
So true. Thank you for that. And we're going to get more into the benefits of that, but that's very cool. Nitric oxide, as you know, is still the best kept secret out there. And the fact that they're putting into the kids' school books, what a step forward. That's pretty awesome. So what is it that made you jump on this nitric oxide bandwagon? What did you find so compelling about it?
Yeah, many years ago, before it became part of our vernacular, and often back then it was often confused with nitrous oxide. There was more often when people say, what are you studying? What are you working on? And this was the days where there's probably a handful of researchers in the academic circles or in institutions were even considering it. This was the day 3 or 4 years before it became the molecule of the year in science, and quite a few years before. 3 thoughtful scientists went on to earn the Nobel Prize in its understanding nitric oxide in terms of vascular biology. But what was most intriguing, I worked in an infectious disease group at Walter Reed Research Institute, and our mandate, our focus was to identify molecules that our body makes that we can turn up or turn on or regulate that may be candidate molecules to control infectious diseases. Everyone's aware of, we're in the stage of learning about immunology the hard way over this COVID crisis. And our focus has been, and you pick up the daily newspaper, it's about a vaccine, and the vaccine makes an antibody, and presumably the antibody is going to neutralize that viral particle or prevent its uptake or infection. There's another arm of the immune system. It's the innate immune arm, or the non-specific arm of the immune system. And it's this part of the immune system which turns on very quickly and is the first line of defense before that vaccine, so to speak, is able to ramp up the immune system to render these antibodies, these neutralizing protective antibodies. So there's an early stage. So to your question, one of our mandates was to better understand what could be those underlying effector molecules that holds these pathogens at bay. And through a very circuitous approach, there was a number of candidate molecules that are turned on by these immune cells early on. And through a really thoughtful network of individuals and scientists, we came together to recognize that it was actually nitric oxide became the putative molecule in which certain types of immune cells are able to be tickled, where it increases the expression of a particular enzyme that makes relatively large amounts of, for a short period of time, of this particular gas, and rendering these pathogens unable to infect subsequent cells. And so our work at that time was really focused on how do we control pathogens once they infect the cell. So our focus was on those intracellular pathogens. Examples that people will recognize is malaria, for example. That's a perfect example. And then there's a number of parasitic infections in which we started screening these nitric oxide and looking at different ways to turn these cells on to make nitric oxide. And lo and behold, we realized not only are these infectious diseases sensitive to nitric oxide, but we were able to turn on this pathway in such a way where we could regulate the growth and even stop further infections. So that's what really got my interest in the early days.
Very cool. So I think the key takeaway for our listeners is, with all that, and of course we love why you got involved, but just how important nitric oxide is for our immune system. That's an interesting thing because I think most of the studies or interest is in cardiovascular health, and rightly so. But at the same time, there's this whole nother side or sides, right? As we know, multifaceted, which we're going to ask you later, all the different benefits that we want to share with you, want you to share with us. But tell us a little bit how your body makes it. Maybe get into the whole nitrite pathway versus the arginine pathway.
Sure. Biology has many redundancies for all the right reason. And this is a wonderful case study of biological redundancies. The primary pathway is our body's able to make it through a family of 3 different enzymes. And literally every cell in the body has the machinery to make nitric oxide. And this is the L-arginine dependent pathway. Our body makes L-arginine. It's hence a non-essential amino acid. And yes, there's dietary sources, and we can come back to the pros and cons of arginine. And these enzymes are able to clip off the nitrogen group, bind it to an oxygen, and creating this particular short-lived gas. And then within that, there's 3 major enzymes that do this. One's turned on actively. This is the one I was making reference to as it relates to infectious diseases, where a number of hormones referred to as cytokines of the immune system or hormones of the immune system turn on and regulate that pathway. And this tends to be more in favor of creating large bursts of nitric oxide for the very intended purpose of immune surveillance. The other pathways, one's particular to our neural system and serves as a regulatory molecule. And another one referred to as eNOS, which you alluded to a moment ago, in which there's a great deal of interest and focus on. And that's found in the cells that line our blood vessel. And this is an enzyme, works in the same fashion, but it's regulated a little bit differently. It has to do with vascular tonality. It deals with the dilation of blood vessels to allow blood flow, but it also is created locally within the blood vessels to prevent our cells not to stick to the lining of those cells' walls. So it serves 2 purposes: vasodilation, enhancing blood flow, and allowing those cells to move readily through our blood vessels without sticking and creating deleterious effects such as clotting. So it plays a very active role. Again, it comes back to a theme you touched upon. It's a very pleiotropic molecule, and it wears a number of different hats, in particular in terms of the vascular system. And that becomes very relevant, matter of fact, as it relates to COVID, which we can touch upon later, which we're learning that COVID is actually a vascular disease, and its impact in terms of on the blood vessels and how it knocks out this particular important eNOS, endothelial nitric oxide synthase pathway. But we can come back to this. So that's the endogenous or L-arginine dependent pathway. The other pathway is the classic non-L-arginine or dietary or non-conical pathway. And this is brought about by ingesting inorganic nitrate. And probably the richest source is within our leafy greens. So when our grandmothers and mothers and great-grandmothers told us not to spit and eat leafy greens, they were very thoughtful scientists. They knew better. And it's these leafy greens in particular that are probably the richest and most robust source. A matter of fact, as science catches up, those commentaries by our grandmothers now has a scientific basis. The best example is the DASH diet, the dietary approach to stop hypertension. It was thought of a certain micronutrients and minerals may be the underlying driver behind that DASH diet, but there's more and more information suggestive that it's actually the leafy greens with an array of cofactors, certain oils and minerals and vitamins in concert, but it's the underlying inorganic nitrate, which is processed in our body, which ultimately makes nitric oxide itself. hence the alternative pathway. And this becomes so relevant, Jay, because as you and I grow a little older and our NOS less efficient. Hence, we become so much more dependent on that second pathway, that dietary pathway, which is affording us this inorganic nitrate, which is bioconverted to ultimately nitric oxide. And that's where these strips come into play. And that's where these thoughtful design supplements come into play of affording us this inorganic nitrate that's modeled really after plant-based diets. And again, it's found within our grains. And we can get in, if time permits, in terms of the nuances of that pathway and as it relates to the strips when appropriate. But those are the two major pathways, okay? The endogenous pathway and the dietary exogenous pathway brought about by inorganic nitrate.
So Shawn, as you know, my first introduction to the nitric oxide story was really with arginine. And so in 2005, all those different individuals, Dr. Cook, Dr. Ignaro, Dr. Prendergast, some of the guys that I really followed, were expressing the benefits of arginine-based precursors. So our M3 is a nitric oxide based, ultimate nitric oxide nutrition based on stoking that pathway in particular. We open the nitrate pathway with some beet powder, but primarily arginine and citrulline, of course, getting phenomenal results, even with our older population uniquely enough. But at the same time, certainly can't deny that nitrate pathway and that's benefits. So my takeaway has been, rather than just saying one or the other, why don't we say yes to both? And the results can be really fantastic. So our nitrate product, our initial one, is Nox3 Greens, 100 milligrams at least of nitrates per serving, which I think we'll talk about standardization a little bit and how important that is as we go along into our discussion. But again, that's our whole focus with BioNox, is really doing what you just explained, really learning that mechanism which nitric oxide can be created, how to do it nutritionally, and certainly the M3, the Nox3 Greens help with both of those.
Join Dr. J next time in episode 2 with Dr. Shawn Green.